Bismillah ar-Rahman ar-Rahim. Welcome everybody. This is a video about undefined integral. Actually, here we have three different types. This is a kind of undefined integral. We use special change of variable. This is a second kind of integral. We use a special change of variable. And this is the third kind of integral. This is about fractional polynomial fraction elementary elements. We have to decompose into elementary polynomials, irreducible one. So let us start by the first one. For the first one, we have to integrate e of x, which is equal to dx over 1 plus x times the square root of x squared plus x plus 1. This kind of integral is of the form, when we have integral from the form x square root of ax squared plus bx plus c dx. From this kind of integral, we are in this situation, and here we have I think 3 or 4 cases depending on A, B, and C, if it has solutions, roots or not, A negative, positive. It depends on the case of the situation depends on the fact on the A, B, and C, the real numbers, and the roots of the polynomial. In this case, x squared plus x plus 1 doesn't accept solution. This one. A is equal to 1, so it is positive. The change of variable here, a good one, is to take the square root of x squared plus x plus 1 equal x plus t. Why x? Actually here the square root of 1x. When we take the power 2, we get x squared. They will be cancelled. From this formula, one has x squared plus x plus 1 equal to x squared plus 2xt plus t squared. Then we cancel x squared with x squared, and we get x times 1, this one, minus 2t. We take this from this one, this side, equal to t squared minus 1. Then x is equal to t squared minus 1 over 1 minus 2t. And 1 plus x, this 1 plus x is equal, we will need it later, 1 plus x is equal to 1 plus t squared minus 1 over 1 minus 2t, which is equal to 1 minus 2t plus t squared minus 1 over 1 minus 2t, and then it takes the final form t square minus 2t over 1 minus 2t, because 1 with minus 1 will be lost. We can write here what we have. We have x equal to t square minus 1 over 1 minus 2t, and 1 plus x equal to t square minus 2t over 1 minus 2t. X equal to t square minus 1 over 1 minus 2t. Let us check for dx. Dx, this implies, this equation implies that dx is equal to 2t times 1 minus 2t minus, so minus plus 2t times t square minus 1 over 1 minus 2t 1 minus 2t plus minus plus 2 from the denominator, t square minus 1. Yeah, sorry, this is the true derivative. The x, let me check once again. We have 2t times 1 minus 2t, it's okay, minus 2 times t square minus 1 dx, which is equal to 2t minus 4t square plus 2t square minus 2 over 1 minus 2t square dt, which is equal to, here we have minus 2t square plus 2t minus 2 over 1 minus 2t square dt. So let us summarize what we get. We get x equal, sorry for the noisy pen, 1 minus 2t. 1 plus x is equal to t square minus 2t over 1 minus 2t, and dx is equal to minus 2t square plus 2t minus 2 over 1 minus 2t square dt. The last thing that we need to prepare is the square root of x square plus x plus 1. This is equal to x plus t. X is equal to t square minus 1 over 1 minus 2t. This is equal to t square minus 1 over 1 minus 2t plus t, which is equal to t square minus 1 plus t minus 2t square over 1 minus 2t, which is equal to minus t square plus t minus 1 over 1 minus 2t. Here we prepare all what we need to integrate this function. I hope that I didn't make mistakes of calculation kind. Anyway, so this integral takes the form, 1 over 1 plus x. 1 plus x is actually t square minus 2t over 1 minus 2t. X 1 plus x. This one. The square root of x squared plus x plus 1 is equal to this one, this times minus t squared plus t minus 1 over 1 minus 2t. And dx is equal to this one, so times minus 2t squared plus 2t minus 2 over 1 minus 2t power 2 dt. Here we can remark that we can cancel this product with this one to write minus 2 from this, minus 2 integral of t squared minus t plus 1 over, here we have t times t minus 2 times we have here minus, so we can take here plus and take here t squared minus t plus 1 dt. We can remark that we can simplify this with this to get just 2 integral dt over t times t minus 2, which is equal to, so it is equal to 2 integral dt over t times t minus 2, which is equal to the integral a over t plus b over t minus 1 dt. This is easy. Which is equal integral 2. We have a t minus a plus bt over t times t minus 1 dt. This means that a plus b is equal to 0 and minus a equal to 1. This means a equal to minus 1. Then a equal to minus 1. This means that b equal to 1. So our integral takes the following form: a equal to minus 1 over t plus 1 over t minus 1 dt, which is equal to minus 2 ln absolute value of t plus absolute value of t minus 1 plus a constant, which is equal to ln as 2 we have here minus 2 for this one, plus 2 for this one, which is equal to 2 ln absolute value of t minus 1 over t plus a constant, which is equal to 2 ln 1 minus 1 over t plus constant. Don't forget that t is equal to, I will write it here, t is equal to the square root of x squared plus x plus 1 minus x. Don't forget the change of variable. This means that this is equal to 2 ln absolute value of 1 minus 1 over the square root of x squared plus x plus 1 minus x plus a constant. We can check if you want that this is the good integral. We can check. We take the derivative of this function. So we have e of x is equal to 2 ln absolute value of 1 minus 1 over the square root of x squared plus x plus 1 minus x plus a constant. So the derivative of this function should give us this integral. This is for the first integral. The second integral is of the kind of function that we have to integrate. We have to, I think that we finish with this. For the second one, this is okay, so we are here. For the second one, this integral is of the form fraction of the square root of 1 minus x over ax plus bx ax power here, power x ax plus b over cx plus d power L1 over n1 ax plus b over cx plus d power lk over nk, such that l and lk and n and xk are natural number. In this case, we take a change of variable by putting ax plus b over cx plus d equal t power alpha, such that alpha is the least common multiple of n1, n2, n and xk. In this example, we have just one square root. This is so L1 is equal to 1 and N1 is equal to 2. Just this one. So we have no more. This is very easy in this case. We have a light calculation to do. So for g of x, which is equal to the integral the square root of 1 minus x over 1 plus x times 1 over x dx. The change of variable that we will take here using this general formula is to take 1 minus x over 1 plus x equal to t power 2 because we have the square root. In this case, we get 2t dt. For example, we have to find first x with respect to t square. From this formula, we get t square plus x t square equal to 1 minus x, which gives us the right to write x times x square plus 1. We move x here to this side, and here we get 1 minus t square. So the first formula is x equal to 1 minus t square over t square plus 1, the first one. The second formula that we need is about dx. From this formula, we get dx equal to minus 2t times t square plus 1 minus 2t times 1 minus t square over t square plus 1 square dt, which is equal to minus 2t minus 2t power 3 minus 2t minus 2t here plus 2t power 3 over t square plus 1 square dt. And here we can remark that we lost this to just keep minus 40 over t square plus 1 square dt. So this is the second important formula in this kind of integral. Dx is equal to minus 40 over t square plus 1 square dt. Let us do some mathematics. Let us calculate this integral. So using this formula, we get g of the change of variable. Let us g of x, g of g of t square 1 minus t square over t square plus 1 is equal to, the first one is t times 1 over x, I mean 1 over x, this gives us t square plus 1 over 1 minus t square times dx, this formula is minus 40 over t square plus 1 square dt, which yields to minus 4 integral. We can simplify this. T square over 1 minus t square times t square plus 1 dt, and this is equal to minus 4 the integral of a over 1 minus t plus b over 1 plus t plus ct plus d over t square plus 1, all this dt. By identification, we can find a, b, c, and d. I will check the time if I have to do calculation or not. It's actually 24 minutes. Let us do it. We have here t square over 1 minus t square times t square plus 1. This is equal to A times 1 plus t times t squared plus 1 plus B times 1 minus t times t squared plus 1 plus ct plus d times 1 minus t squared over 1 minus t squared times t squared plus 1. This is equal the same denominator, but here we get a times t squared plus 1 plus t power 3 plus t plus b times t squared plus 1 minus t power 3 minus t plus, from this formula we have ct minus ct power 3 plus d minus dt square. Don't forget this formula. Which is equal to the same denominator. T power 3, we have a t power 3 plus minus b for t power 3 minus c for t power 3 times t power 3 plus we have a for t square plus b for t square minus d for t square plus a for t minus b for t plus c for t plus we have here a, here plus b, and here plus d. This is what we need over the same. From this we get what? From this we get the following linear system. A minus b minus c equal 0. A plus b minus d equal 1. A minus b plus c equal 0. And a plus b plus d equal 0. We have 4 equations and 4 anonymous coequation. We will try to find the solution if it is if we can apply Fontaine-Rouchy-Kramer theorems or not. So for this equation, if we add those equations, we get here we have to keep 4 equations. So the first one is A minus B minus C equal to 0. The second equation is A plus B minus D equal to 1. The third equation, we will add the first one. So we add to the third one, the first one, we keep 2 A minus B equal to 0. This means that A equal to B. This from this equation. If A is equal to B, this means that A minus B is equal to 0. Then C is equal to 0 from this one. C equal to 0. A equal to B. This means that here we have, for example, here we have 2A. So A equal to B. We have here 2A equal 1 and 2A equal to 0. I think that I do mistakes. I'm mistaken about the calculation. T square plus 1 plus T power 3 plus T plus B. A equal to B. If we add this to each other, we get A minus B equals 0. This means A equal to B. If A is equal to B, this means that C is equal to 0. Okay. I think that it seems that it is good. I minus B equal to 0. This means I equal to B. It's okay. So here we have 2A. We have 2A minus D equal 1. And we have 2A plus D equal to 0. Okay. If we take the sum, we get 4A equal to 1. This means that A is equal to 1 over 4, which is equal to B. Yeah, we solve it here. C equal to 0, that we need D. D is equal, for example, here we have 1 quarter, so we have 1/2 plus D equals 0. D is equal to minus 1/2. And D is equal to minus 1/2. Yeah, I think that we finish. So this formula takes the following formula. This is equal to A over it gives us 1 over 4 over 1 minus T plus A is equal to B plus 1 over 4 1 plus T plus C is equal to 0. This D is equal to minus 1 over 2 over 1 plus T square. Let's check once again to be sure. So here we have 1 over 4 times we have 1 over 4, we have 1 plus 1, this means 2, this means 1 over 2, 1 minus T square plus minus 1/2 over 1 plus T square. This gives us 1 over 2 1 plus T square minus 1 over 2 1 minus T square over the times we get minus plus 1. It's okay. I am happy the calculation were true. our calculation were true. Then to integrate g of x, we write g of some things with respect to t. The t, I think 1 minus t square over 1 plus t square, if I remember. This is equal to minus 4, the integration of 1 over 4, so here 1 over 4 over 1 minus t, plus 1 over 4 over 1 plus t, plus minus 1 over 4 t square plus 1 dt, which gives us, we can simplify, so we have here minus with this minus, it gives us just ln 1 minus t, and here we have minus with this, so it gives minus ln 1 plus t, minus with minus, it gives us 2, so plus 2, and this is arc tangent t plus a constant, which finally turns to ln absolute value of 1 minus t over 1 plus t, this one, plus 2 arc tangent t plus c. And here we need to turn back to the first integral, the first variable, that I mean g of x is equal to ln absolute value of 1 minus the square root of 1 minus x over 1 plus x over 1 plus the square root of 1 minus x over 1 plus x plus 2 arc tangent 1 minus x over 1 plus x square root plus a constant. This is I think the final result. I hope that this was useful. Thank you very much for watching. See you next time.